Hi students, this is Chapter 8, Lesson 2. The topic of this lesson is function rules. First lesson in this chapter we looked at function tables. Today we're going to look at function rules. I'm also going to start putting this number right here, meaning that this is the second note page for Chapter 8. Alright, let's go ahead and get started. We do have some vocabulary today as well, just like Lesson 1. The first word I want you to write down is a sequence. Okay, in math, a sequence is a list of numbers in a specific order. So, let's write that down. List of numbers in a specific order. Another way to think about that is there's a pattern to the numbers. Here is an example of a sequence. And I think you'll be able to see what I'm talking about in this example. Here's a sequence of numbers. 5, 10, 15, 20, and the sequence could keep going. Another vocabulary word is a term. I know that we've talked about a term in an expression before, but if you're looking at a sequence, a term is each number in a sequence. So these are terms. 5, 10. So a term is each number in a sequence. So, sequence is a list of numbers in a specific order or a pattern, and a term is each number within that sequence. So, sequence is a key vocabulary word for this lesson, and so is term. Okay, so two different types of sequences that I'm now going to talk about. The first one is called an arithmetic sequence. Okay, and in an arithmetic sequence, what you're doing is you're adding the same number to each term. Adding same number to each term. Adding the same number to each term. And in your practice today, you're going to be looking at sequences, and for a lot of the questions, you're going to be answering two different things. You're going to describe the sequence with words and answer like the next two terms of the sequence or the next three terms of the sequence. Here is an example of an arithmetic sequence. 4, 8, 12, 16, and you might be asked to determine the next three terms of the sequence, which I think you could do. What's happening as we look at this sequence? Well, each term, 4 is being added. 4 plus 4 is 8. 8 plus 4 is 12. And 12 plus 4 is 16. So to get the next term, we would add another 4. We would add another 4 and add another 4 to get to the next three terms. Or we would be skip counting by 4s. So that is part of your practice today. Now, a word description might sound something like this. The description for this sequence. So again, you're going to be doing two things. Okay, identifying the next terms, and that would be add 4 onto this, add 4 onto this, add 4 onto this. There are the next 3 terms. And the description in words, if you were to write a description in words, it might sound something like this. Each term is found by adding 4 to the previous term. So you add 4 to the previous term to get the next term. That is an arithmetic sequence. So 2 things you're going to be doing today: find the next few terms, however many it asks for, and come up with a description. Please read your directions carefully. It's not just finding these, it's also asking you to describe the sequence. Another kind of sequence is called a geometric sequence. In a geometric sequence, you're multiplying each term by the same number. So, multiplying each term by same number. So, here is an example of a geometric sequence. 3, 9, 27, 81, and you might be asked to find the next 3 terms as well. So how did we go from this term to 9, 3 to 9? It was times 3. How did we go from 9 to get to 27? Times 3. How did we get from 27 to 81? Times 3. And that pattern is going to continue for the next 3 terms. And of course, you can use a calculator if you're showing your work. So also the description. Each term is found by multiplying previous term by 3. Each term is found by multiplying the previous term by 3. So again, description and finding the next 3 terms. If I used a calculator to find the next 3 terms, 81 times 3 would give me 243. 243 times 3 would give me 729. And 729 times 3 would give me 2,187. All right, so 2 different kinds of sequences. An arithmetic sequence, you're adding the same number to each term, and geometric sequence means you are multiplying each term by the same number. And I'm just going to separate these a little bit in my notes. I'm going to draw a line like this, separating those 2. Okay. Last thing we're going to look at is, actually before we do that, here's your hidden treasure. Your hidden treasure today is another key vocabulary word. You can write it on your notes. Maybe down at the bottom would be a good place. The hidden treasure for today is, what is a rate? R-A-T-E. If you can give me the definition of a rate and an example of a rate, you will win the hidden treasure as long as you've got all your Chapter 8 notes. Look back through notes. You can use your glossary. You could use a Kids Math Dictionary. The link to that is in Google Classroom. Look it up. If you don't remember, we covered that early in the year, in first quarter. Again, hidden treasure is define and give an example of a rate. Okay, moving on. The other thing you're going to be practicing today is, actually before I talk about the next thing, I want to quickly talk real fast about tables, function tables, or tables in general. The tables we looked at in lesson 1 were tables with columns. They had different columns for the x value, the function rule, and the y value. And a lot of the times, tables are shortened. They're not going to include that rule, the function rule part. So here's what we looked at yesterday. We had an x value, we had a rule, and then we had a y value, and our tables looked like this. Well, oftentimes this rule right here is not even included. So your tables are just going to look like this. They're going to have an x value and a y value, and your tables are just going to look like that. But you should know that there is a rule table that goes from the x, what rule gets used to give you the y. But they often don't even put this part. It's like this. Getting rid of that, the rule table, you're just going to see that part, okay? But you can think of that rule table as in between. Also, you might see tables written in rows. These are columns where the values would go down. Tables can also be in rows. So that would look like this. You might have x values, and then you could say the rule, and then you'd have the y values. So it's just like this, but it's turned into rows, and your values would go this way. Instead of going down, they would go across. And the rule here would be your x value. What's the rule that gets you to the y value? But just like this, oftentimes this rule is not even shown in the table, that rule row. You are just going to see a table that looks like this. It'll have an x value, a y value, and that's it. But again, you should know that there's a rule that gets you from the x value to the y value. So that's just a real quick description on tables and how this rule part of your tables are going to most often be disappearing. But it's really there. Okay, next you're going to look at a sequence in a table and try to find the rule. So let's look at an example. So we're going to look at a sequence in a table, and we're going to find the rule. So we're going to look at some values, x and y values. They might not be called that. Often today they use position, the position number of a sequence, like position 1, position 2, position 3, and then the value of that position. So let's look at an example. Here's a table, sequence in a table. The value 1 gets you, position 1 gets you a value of 5. Position 2 gets you a value of 7. Position 3 gets gives you a value of 9. And let's see, position 4 gives you a value of 11. And after that, I'm going to use a variable n for any number position. Okay, so let's put this in a table. So this is a table that has rows. It's like this example right here. The rule table is not pictured, but it's right in between. So another way to think about this is, what's the rule? Okay, the function rule is going to go down. I'm going to write that. The function rule that we're trying to find goes like this. In other words, what's the rule that gets me from 1 to 5? What's the rule that gets me from 2 to 7? What's the rule that gets me from 3 to 9? And what is the rule that gets me from 4 to 11? So I'm going to highlight that. This is the pattern we're looking for, the function rule. In this example, it's going down from the position number to the value, or from the x to the y. It's another way you could think of that. So something else, and this is a pretty tricky rule right here, this example that I've given you. And one thing that you have to know is that the rule always has to work. Right here, somebody might look at this and go, aha, the rule is times 3. 3 times 3 is 9. And that works for this right here. However, it does not work every single time. 2 times 3 is not 7. 1 times 3 is not 5. So my function rule, it is not times 3, even though it works here. Your function rule has to work every single time. So here is a way to get started when you can't see the value right away. Look at the change in the y values. How is it changing from 5 to get to 7? Plus 2. From here to here is plus 2. From 9 to 11 is plus 2. When you see that change in the y values, a consistent change, plus 2, plus 2, plus 2, that means that part of your rule is times 2. And then you have to figure out what the rest of your rule is. So if you're adding 2 to each value of y, that means part of your rule is going to be times 2. What's 1 times 2? I would get 3. What's 2 times 2? I would get 4. What's 3 times 2? I would get 6, not 9. What's 4 times 2? I would get 8, not 11. But what gets me to that value after I've multiplied it by 2? Well, look at number 1. 1 times 2 is 2. How do I get to 5? Add 3 more. 2 times 2 is 4. How do I get to 7? Add 3 more. 3 times 2 is 6. How do I get to 9? Add 3 more. So that is the rest of your rule. The rest of the rule would be times 2 plus 3. So again, that's kind of a tricky one. When you see this pattern in your y values, you're adding the same number. That means part of your rule is going to be times whatever that number is. Plus 2, plus 2, plus 2. Part of my rule is times 2. I have to figure out what the rest of that rule is. And in this case, it was plus 3. So that means for any value n position, my rule is 2n, which means 2 times this number, times 2, plus 3. This is my rule that works You could ask, what's the 6th position in this sequence? Without even figuring it out, by filling in the table, I could plug in 6. 2 times 6 is 12, plus 3, that value would be 15. I could even go way out to like the 337th position, way out there. Multiply it by 2, add 3. That's what the value of that position is going to be. All right, so pretty complicated function rule here. A lot of times it won't be this complicated, but today this is what you're looking at. 2 different kinds of sequences, describing them, finding the next values, and then looking at a sequence in a table and trying to find the rule. Okay, that does it for lesson 2. I'll see you soon for lesson 3.